Well, good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com program, brought to you by Techstrong, AWS, and Aqua Security. My name is Cody J. Brown, host of Techstrong Learning, and we have an exciting panel ahead. First, I do have just a couple of housekeeping notes to cover. Today's session is being recorded, so if you miss any of our discussion, or you'd like to maybe rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, and we sincerely hope you do, we want you to send those in to us using the Q&A tab, which can be found on the right side of your screen. We'll be hosting a Q&A toward the end of the program, so we will address as many as we can in maybe the last 10 or 15 minutes of today's program. On the right side of your screen is where you'll also find the chat tab. This chat area is where we want you to get to know your fellow audience members, or maybe just let us know from where you are joining. If you navigate to the handouts panel, you'll see a document there available for download, and that is free to you as a resource and aid with today's program. And of course, before we close out, we are giving away 4 $25 Amazon gift cards, so be sure to stick around. So our topic today is Security and Assurance for AWS Fargate Containers, a how-to session. I'm joined by Stephen Follis, Container Specialist at AWS, and Farhan Mohsin, Partner Solutions Architect at Aqua Security. So Stephen, Farhan, thank you both so much for joining us today. Stephen, you want to go ahead and take it away from here?
I sure do, and thank you so much, Cody. Appreciate your help. Hi, everyone. Welcome to the webinar today. We're going to jump right on in with our agenda. Where first we're going to start out talking about the AWS Fargate service. We'll talk about the operational agility, security benefits, and the capabilities of the platform first, and then we'll also expand out into the tooling and capabilities of Aqua's products and how it's able to go above and beyond what Fargate does in terms of pipelining, assurance policies, detecting unauthorized activities, and several other capabilities that provide an incredibly cohesive security story for your containerized workloads. I'm Stephen Follis. I work at AWS as a container specialist on our go-to-market team focused on Fargate. Joining me today is Farhan Mohsin, who's one of the partner solution architects at Aqua. And so we're excited to jointly bring this content to you today. So let's talk a little bit about Fargate. So with Fargate, we like to describe it as a serverless compute engine for containers. All that's really meaning is the serverless piece is talking about shifting responsibility from yourself over to AWS for portions of the workloads. So if you've utilized Lambda in the past, or Aurora DB, or other serverless services in AWS, you know that there's not EC2 instances that you have to manage there. It's the very same here for Fargate. So we're taking away the EC2 instances, the requirements of running and operating massive fleets of virtual machines, and instead allowing you to focus in on your containerized applications. Additionally, when we say compute engine, this is referring to the fact that Fargate, while it's a great brand that we know and love, it is a capability, it is a feature of the AWS Container Services platform. And so we interface with Fargate, we pay for Fargate, we use Fargate through the lens of one of our container orchestrators. So Fargate is not its own orchestrator, but it is a capability that is expressed through either ECS, the Elastic Container Service, or EKS, the Elastic Kubernetes Service, both of which have the capability of deploying, operating, and scaling serverless containers through Fargate. With Fargate, as we're talking about the different types of workloads that we see customers utilizing today, it's really a general use platform. So if it runs in a container, Fargate runs standard OCI containers, chances are that it's going to work just fine on Fargate. And so the kinds of workloads we see break down into several buckets. Two of the most common, which are elastic scalable web applications, where we need to be able to dynamically change the amount of capacity based on user demand. And then also data processing types of applications, where we want to utilize containers to be able to read off of a queue, do compute kinds of workloads, and have some sort of output, both of which are very common that we see in various shapes and sizes on top of Fargate, and areas that we see customers really finding value in Fargate with. So when we talk about shifting responsibility, what does that look like? So here on the left, you see what we're calling traditional EC2 instances. So in the container world, really since the dawn of containers, we've had a very similar setup where we take multiple virtual machines, we then cluster those machines together, and then we use a container orchestrator on top to manage what's running on each machine. In the EC2 world, this means that AWS is going to take care of our physical data center for you. We're going to give you a virtual machine. But from that point forward, everything within that virtual machine is your responsibility. So you've got to select an operating system. You need to be managing the patches for that operating system month over month. When it comes time to upgrade that OS, that's on you. And then additionally, specific to containers, we have several different components that we think about, such as the container runtime. This is something like the Docker daemon, container D, etc. Observability plugins, orchestration agents such as the ECS agent or the Kubernetes kubelet. All of these are components that are deployed into these EC2 nodes that we have to version, we have to update, we have to upgrade, and manage over time. And this is all before we've even gotten to your containerized applications that run on top. So there's quite a bit here that an operator has to focus on and has to use. And this is very appropriate if you have a workload that needs very specific, very niche configurations for the operating system or the kernel or specific kubelet flags you need to pass in. Complete control here on EC2, and it's a wonderful option for a wide variety of workloads. However, we hear from customers that are running containerized applications that in many cases, they don't need that level of control. That level of control is often, undifferentiated heavy lifting, as we like to say here at AWS, where it's taking away valuable time and resources for their environment. They're simply looking for a more managed experience where they can bring their application and everything underneath that application is AWS's responsibility. That's where Fargate comes in, and where we hear from customers all the time that it's enabling them to supercharge their environments and their deployments by being able to leverage the managed service abstraction that is Fargate, whether that is an ECS task or an EKS pod. We have this ability to take on much of that responsibility here at AWS. Taking this responsibility on allows customers to focus on really the solving the harder problems when they're deploying containers, right? So deploying 10 containers on my laptop, very easy, very straightforward. But when we start talking about multiple different ECS or EKS clusters that have dozens or hundreds of nodes in multiple environments, the permutations get out of hand very quickly. It can be cumbersome from an operational perspective. And so Fargate provides us with a variety of capabilities that make it easier to deploy, operate, and maintain these clusters of container workloads in a very straightforward manner. So first off is maintenance. So we've alluded to this a bit here on AMI management, right? So we have many customers who, if they run EC2, you have to run a golden AMI image that's approved by the organization, by a security team, by a governance team. We have to have a litany of different agents installed, certain configurations. That can be challenging, especially when we have dozens or hundreds of nodes that each month we have to make sure are patched, upgraded, that we validate those changes, that we roll those changes out. There's a lot of operational minutia that goes into this. And so we have customers that report, hey, we spend 10, 20, 30 hours a month, every single month, managing these massive fleets of EC2. By moving to Fargate, we can take those 10, 20, 30 hours back, depending on what it takes you to operate those environments. Fargate makes all this go away by leveraging Fargate, where AWS is the one that's managing all these updates and upgrades. If I have an application that I deployed last month, by simply redeploying that application, I'll be taking advantage of all the latest updates to those AMIs that are running under the hood of Fargate automatically. There's not other pieces that we need to add there. So some customers specifically choose Fargate to get around some of the onerous governance requirements that they have for EC2 and to take some of the time back in their month and focus it in other areas. Additionally, capacity management is one that we often hear is a challenge, where we're trying to juggle the amount of compute resources we have available with the demand that we see from end users. And the complexity is often driven by, there's a couple different layers we've got to think about. The first layer is the number of containers that we are deploying and that we're managing. We can easily scale that out, scale that in through either Kubernetes horizontal pod autoscaler feature, HPA, or through an ECS services ability to do a variety of different autoscaling algorithms. And so we can really tune the number of containers that we need. Sitting underneath that layer is this infrastructure layer. And that's all about, do we have enough EC2 or other compute to power the containers that are sitting on top of it? And so this is something like the Kubernetes cluster autoscaler, or an ECS, something like an EC2 autoscaling group, for example, where we're trying to juggle the right amount of compute resources for those containers that we need. In the Fargate world, that entire bottom layer, that infrastructure layer, goes away. So we can get rid of that. If you need more capacity, you simply scale up an ECS service or a Kubernetes deployment, and that capacity is provided by Fargate. There's nothing to go out and provision, or to do. It's automatically there for you. This is an incredibly useful capability, especially when we're trying to have just the right amount of capacity for those workloads, and simplifies what we have to think about from a capacity management perspective. Closely related to capacity is cost. And so we see if we've over provisioned our capacity, that gets expensive and gets very costly. It is very common in the industry to see clusters that are running at 20 or 30% utilization, even call it 50% utilization. In those environments, you've got every 50 cents of every dollar is being wasted in that infrastructure. Fargate helps here as well by allowing us to more granularly allocate resources, and therefore what we pay, on a per pod or per task level, rather than at the underlying node level. In EC2, we size and do all that allocation at that node level. And we're really hoping we can bin pack enough containers into that heterogeneous node so that our utilization gets up beyond 50%. Oftentimes that's challenging. And so we keep that over provisioned EC2, and that's expensive. With Fargate, I can have very granular control. So workload A that I'm deploying, that may be doing a Monte Carlo simulation. I need lots of horsepower, all the vCPU and RAM I have available. We can pump that into workload A and allocate it just for that workload. For workload B, it may be much lighter. We're reading some data out of a cache, doing some presentation logic. Very lightweight. I may need just half of one vCPU, a very small amount of resources. Instead of trying to co-locate both of those on the same node, Fargate deploys those into their own environments with different levels of resources, thus allowing me to really dial in the cost on each workload, thus getting better utilization and better cost for those environments, which is very powerful. And that's all before we've even talked about things like compute savings plans, spot instances, and Graviton2 as additional ways to really optimize the spend that we operate with Fargate. Shifting over into focus, this was back into how much time are we spending every month focused on our environments and our infrastructure versus our applications. So the dream of containers was to really supercharge the development and DevOps experience, where we're able to faster than ever before deliver code, deliver value to our end users. But in many instances, we're spending as much or more time making sure we're keeping the lights on infrastructure, and that's a lot of time every month. So Fargate allows us to really get back into let's fix bugs, let's ship code, let's enhance the value out of that code versus just keeping some of the infrastructure going there. And so our focus can really get back into applications more than ever before. Finally, security is on top of everyone's minds. It's job zero at AWS, something we take very seriously. And from the very beginning of Fargate's introduction, one of our core tenets of design has been around security. And so in the container world, most environments are really focused on that heterogeneous clustered experience where you've got bin-packed containers. Fargate is different. Every time you deploy a containerized workload on Fargate, we are wrapping that environment in a micro virtual machine. So there's a VM that's that is containing that container, right? So we're not only relying on C groups and namespaces, we have a hypervisor, we have a hard shell around that container. We have a dedicated ENI that is allocated to that workload. That can be locked down through standard mechanisms like AWS security groups. And so we provided a heightened level of isolation than what we have in a typical heterogeneous node type environment. This is important. It's something that provides an additional layer of security without impacting the customer experience, the user experience of deploying applications. It doesn't slow you down. You get it by default. Whether that's an ECS task or an EKS pod, you're being isolated in that environment. Additionally, we do not allow, today we do not allow privileged containers, underlying host access, and a variety of other kind of lockdown defaults into Fargate that allow more peace of mind when it comes to security conversations around our containers. And so security is paramount to Fargate. It has been since day one, and it will continue to be for the lifetime of the service, and something that we pride ourselves very heavily on. But as strong as Fargate is, it's one piece of the overall story, of the overall puzzle when it comes to a given workload. And so what we're going to do now is shift and talk a little bit about how Aqua's tools and capabilities are able to complement Fargate and to provide a much more holistic end-to-end security solution for your serverless containers that run on top of Fargate. So Farhan, I'll happily turn it over to you at this point.
Thank you, Stephen. Thank you for moving that over to this slide. So hi, everyone. So basically, I'll talk about, give you an intro about what Aqua is. So in short, the heading of this slide explains what Aqua is. Aqua is a CNAPP, or Cloud Native Application Protection Platform, as Gartner so eloquently called this term. They came up with it, I think, August of last year. But with Aqua, we've actually been following this principle since the inception of Aqua. So where Gartner was looking at this concept as, cloud native security is a holistic effort, which involves securing your cloud native application throughout its life cycle. Aqua has been doing that since the inception. We look at it from, again, similar approach. We look at it from securing your applications when they're being built by trusting your code, that you're building secure artifacts from the get-go, and Aqua helps you secure those artifacts. And then once your artifacts are built, we want to make sure that the infrastructure that they're running on, that is secure and configured properly, so that we have to make sure your infrastructure is hardened. And finally, the last part is the runtime side, where we want to ensure that, hey, while your applications are running, they are properly protected and they're doing what they're supposed to and nothing else. Again, some of the similar terms that Gartner uses on the runtime side, they call it Cloud Workload Protection Platform, or CWPP, which focuses on the runtime. CSPM, which is Cloud Security Posture Management, that focuses on a security posture for your cloud environments. But with Aqua, if you look at it here, we look at it as a one unified platform where we're able to protect your cloud native applications or your containerized applications from the time they're being developed all the way through runtime, and we actually do active protection. And recently, with the acquisition of one of the companies that Aqua did, we've actually moved further to the left, if you want to call it, like if you consider the left side, which is securing your applications when they're being built. We've actually been able to shift further to the left and actually secure the supply chain side of your software, where Aqua is now able to protect your applications while they're being developed by your developers, as by integrating into source code management systems like GitHub, GitLab, and equivalent of that we have in AWS side. So the idea is Aqua provides a fully comprehensive security solution for your containerized or cloud native applications. So this slide kind of provides, I know it's a busy slide, but actually provides a lot more details about the Aqua platform. So if you look at in the center part of it, the three things that are listed in the center part of it are, again, talking about the build side, we're shifting left, we're able to do vulnerability scanning. And the next part is the dynamic threat analysis. That's something pretty unique to Aqua, where Aqua is actually able to do behavioral analysis on your images that are being built and catch any of those hidden issues that only show up at runtime as the container is spinning up. So Aqua is able to catch that as well. Aqua is able to do infrastructure as code template scanning, and so catch up with, if you have any misconfigurations with your AWS, CloudFormation templates or, Terraform templates, we'll be able to catch that. And then talking about the, on the build side, the supply chain security piece is where we're able to actually help build secure artifacts from the get-go. So we already were doing, vulnerability scanning and behavioral analysis after the images were being built or just as they were finishing to be built. But now we can even move further to the left and help build secure artifacts as you're building your containerized applications. And then if you look here in the middle, we have two parts for the infrastructure where we focus on cloud security posture management, where we're able to make sure your cloud environment with your systems are going to be hosted where it's the Fargate type of environment or any other type of environment with AWS will be able to help make sure that your systems are adhering to industry best practices and benchmarks, as well as complying to all the different compliance policies that you may have out there, like PCI, HIPAA, high trust, those kind of policies. And then the other part that Aqua specializes in is something called, KSPM, we call it, or Kubernetes Security Posture Management, where Aqua is able to help um, secure and properly configure or help identify any misconfigurations in your Kubernetes environment and make sure that Kubernetes environment's configured properly to run your containerized applications. And then on the runtime side, we're actually able to do active runtime protections. Aqua is one of the, if not the only solution out there that does active runtime protection and actually can block and prevent attacks on your cloud native infrastructure applications at runtime. And then we're able to do that using our cloud native detection and response mechanism that we've come up with, which utilizes eBPF technology, which is kind of focusing on your system calls at the Linux kernel level. And then, of course, we have ability to do some firewall rules around, contextualized firewall rules around your Kubernetes containerized environments. And then something unique that Aqua recently came up, again, a new item is called Aqua Hub, which actually sits on top of all of these information and tries to link all these issues that you find in different areas and contextualizes the risk posture for your whole environment from these different sections, from your infrastructure, from your runtime side, and as well as from your image building side, and provides you more insights into what could be wrong with your environment. And we'll have a look at that in our demo when I talk about it. And then moving further outwards from this slide, you can see all the different tools and technologies that Aqua can integrate with or protect against. So the idea with Aqua was to make sure that the security platform is not a hindrance. In fact, it's an enabler for the development teams, the security teams, the ops team to do their job effectively. So we pretty much integrate with every tool and technology that's out there. And in this specific instance, if you look here, we're very well integrated with all the different offerings and services that AWS provides, whether it's your CI/CD pipelines, Aqua can integrate with that, whether it's your image registries, Aqua is able to integrate with that. Aqua is able to protect your containers in the ECS environment or Bottle Rocket. We're able to utilize, EKS environment, EKS anywhere, Red Hat, OpenShift. Like we're able to integrate with pretty much all the offerings that AWS provides. We're able to protect your serverless functions at runtime, the Lambda functions. And again, when we're talking about Fargate, container as a service setup, we're able to provide protection for or vulnerability scanning and protection for your underlying host, where we're able to scan, EC2 hosts or running on Graviton 2 as well. If we have any vulnerabilities listed there, we can integrate with different secret management tools that are out there to seamlessly transfer your credentials over to running containers. And we can provide all that information integrated into different SIM and analytics tools and pass that information where it needs to go, whether it's different ticketing systems or just analytics tools. We can integrate with pretty much everything out there. I won't go into the details, but these are different. These icons, colorful icons that you see on the screen are open source products that are out there. Aqua is a strong component of strong proponent of open source technology. So we kind of invest heavily in our open source teams as well, where they develop all these different tools and technologies for different sections of the cloud native protection space. One of the most popular item I want to mention here is the Aqua Trivi, which is the most popular vulnerability scanner that's out there, open source scanner out there, that developers use while they're scanning their images that they're being built. It's got over 100 million users already, and over 100,000 downloads almost every day. I just wanted to highlight that. With that, I just kind of want to focus on, the Fargate side of things. So how can Aqua help protect your Fargate applications as you're developing them? So like I said, first thing is we shift left. We try to make sure that as your apps are being developed, we make sure that they're secure by doing a comprehensive and accurate vulnerability scan, and make sure that we don't get any false positive to ensure. And again, if you have CI/CD tools, we can integrate there and actually move further to the left and scan your code or artifacts as you're building them, and make sure that you're doing all of that. You're able to build secure artifacts from the get-go. And then in addition to that, I'll show that in my demo as well, is that Aqua can actually help you provide a contextualized or prioritize information about what issues to fix first. Once you find those issues, you may need help figuring out which ones to tackle first, which again goes hand in hand with helping with operational efficiencies. So Aqua is able to provide that as well with our risk-based insights, and I'll give you guys a quick glance at that as well and later on in the demo. So how does Aqua do that piece? So Aqua is a policy-driven tool where you're able to set up different policies at different stages of your modules, and basically it helps you define what's good for your environment and what's not. So anything that's not compliant or not approved can then be marked to not be allowed to run in your environment. Or you can integrate with your CI/CD tool and enforce that, hey, as long as this image that's being built is non-compliant, it will not be allowed to build. So you can set up those policies and fine-tune them and tweak them as you go along, and in combination with these policies, we'll be able to make sure that you're building secure artifacts and utilizing them in your environment. So after you've kind of ensured that you're building secure artifacts, then it doesn't really guarantee that what you're running in your environment secure. You don't know, there may be some weird zero-day attacks that can come through, or some encrypted information or encrypted code that may have passed through that didn't get caught during the vulnerability scanning. And so you still need to have runtime protection to ensure whatever your applications is supposed to do, it's only doing that and nothing else. So with Aqua, we can actually do that runtime protection for a host of different environments. But in this specific case for Fargate, we have a dedicated enforcer that's deployed in your production environment with your running workloads or applications. It's called the micro enforcer. So it actually runs side by side with your running containers and ensures that, the runtime policies or the policies that you've set up to ensure that your application is supposed to do, it ensures that it's only doing that and nothing else. So this micro enforcer can actually run either as a sidecar, or it can actually be embedded as part of your application. So whenever the container is launched, micro enforcer can be launched with it. And again, the idea here is it helps you provide that close control right next to your workloads, so that you're getting the up-to-date latest, runtime protection of your applications, while they're running, and you can actually stop attacks from happening. If somebody is able to gain access to your container, I don't know how they will, but in an instance, if they were able to, and they downloaded some file or something like that, or modified a running executable that was considered good, Aqua's micro enforcer will actually prevent that modified file from running, and it will ensure your containers run as immutable containers, to kind of follow the container immutability concept. And something pretty unique to Aqua that we've developed in addition to that is for the EKS environment on Fargate, where we're actually provided an additional feature where we're able to actually do this deployment of the micro enforcer on automatically, and I'll talk about that in my next slide here, next couple of slides. But then again, it's actually, if in an instance where you're utilizing Fargate on EKS on Fargate, we're able to actually make it, the management of your runtime enforcer becomes even easier. So again, how do we do the runtime controls? It's all defined through policies. You have several different controls that you can set up for your micro enforcers, and it actually looks at those policies and ensures that your application, is doing what it's supposed to and nothing else. You can, check for file integrity. You can check block reverse shell. You can block crypto mining. You can actually block non-compliant images that Aqua is deemed as not approved to be run in your environment, to be blocked. So micro enforcers can ensure that, hey, if a container tries to block, images run that's non-compliant, we can block that from even running in your environment. So there's a host of different controls you can utilize with the micro enforcer. And then this is a screenshot of that extra item that we integrated with EKS on Fargate, where another tool that we have, which is called Kube Enforcer, that manages cluster level security for your Kubernetes environment. So if you have that running in your environment, by enabling this one single check, which is pod injection, what you're essentially doing is letting Aqua handle the automatic injection of those extra sidecar containers into your, as soon as quickly as soon as a new Fargate container pops up on EKS, Aqua can automatically inject the micro enforcer with it and make sure that you're protected from the get-go. So this is another innovation that Aqua has come up with, working with the AWS team and ensuring that this is fully integrated with the AWS ecosystem. All right, with that, I'm actually going to quickly move on to our short demo of our environment. So I'm going to go ahead and switch over. So, all right, so here we have our Aqua Hub, or the Aqua dashboard. Once you sign in, that's what you'll see. So here you actually have all the three different sections that show up. We have the supply chain side focusing on the left side, CSPMs focusing on the cloud security posture management, and the workload protection focuses on your images and your container security piece, which this is the part where we'll be focusing on pretty much for most of the demo. But before I move on there, I actually want to quickly showcase our Aqua Hub that we recently launched. What this Aqua Hub does is basically it sits on top of your the three modules and actually gathers information from that those three environments, puts it in a data lake, and then we utilize that to build contextualized risk posture for your environment and kind of tell you what's going on in overall. What risks are available in your overall environment. So here, and it kind of comes up with these insights for you. So in this case, if you look here, we have workloads with privileges to the underlying privileges to underlying host have remote exploitable vulnerabilities, or workloads with excessive privileges to cloud resources have remote exploitable vulnerabilities. So if I click in there, I'm actually able to see that it takes me to that particular problem. So the idea here is you may have found these issues in two different sections of Aqua. Let's say the cloud excessive privileges part was captured by the CSPM module, but the remote exploitable vulnerabilities were captured by the workload protection piece. But we're actually putting two and two together here and kind of providing you that information about that compounded risk in your environment, and actually providing you details here like, hey, these are the vulnerabilities that you have to look at to fix, and then if you have any remote or excessive privileges set up, you need to go fix those. So it actually provides you all those details right in this dashboard for you to use. And similarly, we provide this quick information about your cloud infrastructure's compliance to the different pre-built compliance programs that we already have, and then map it against, how good or bad your environment is compared to those compliance policies. So in this case, if you look here, we're 72% compliant with the AWS well-architected frameworks. And again, it's a very, very easy mapping, and it kind of provides you a quick glance how how your environment's doing across different compliance. And then you can drill down into these particular issues and go find what those problems are, and it'll take you to the specific CSPM module and give you more details there. And then again, with the hub, the idea here is to provide that overall big picture information for your security team, so they can quickly assess and go figure out what needs to be fixed, rather than spending time figuring out what needs to be fixed. Another thing I would quickly highlight here is we're able to actually provide an inventory of the different resources that you have that have a risk associated with it, and you can kind of filter these out with different filters, which kind of tells you your internet exposed resources, or if you're just looking at VMs or just functions, you can kind of um, filter those out, and it'll tell you the risk posture of those particular resources. So the Aqua Hub is a really good tool to be utilized by your security team or operations teams. And then let me move to the workload protection piece here. So here, workload protection, when you log in, you're going to see this little dashboard. This is going to show you a quick snapshot of your environment, what's going on. These are all configurable. These widgets are all can be moved around. And all of this is controlled through role-based access control. So you can actually set up permissions where certain teams can view only the stuff that they need to. So it's all configurable there. The next item that I just want to show you here, another cool feature that our team came up with was this Risk Explorer, which is basically a 10,000-foot view or a bird's eye view of your Kubernetes environment, and kind of giving you an idea of the risks involved in your running workloads right now. So you see here all these different workloads are running, and the color coding is kind of giving you an idea of how bad those vulnerabilities exist on these running workloads. And what you can do is basically click on them, and it actually takes you to those underlying risks, whether they're part of the image that the workload is using or the underlying host that it's running on. So you're quickly able to gather information about the risks or vulnerabilities involved with your or your running workloads in your environment. So if I click here, it just basically takes me there, and it's telling me like what's wrong with my environment. I did not comply to this default policy, and then this image has a host of different vulnerabilities. All that information shows up here. All these details are here. And if there was a fix associated with it, it's going to tell you the fix version. If there was a exploit available, you can click there, and it'll take you to the actual exploit that's available on the exploit DB. And rest assured, if it's available on the public network or publicly available website, somebody is trying to stop you from using it, or is trying to exploit that vulnerability in your environment. Again, the idea here is to quickly help get people to the troubled area in your environment. And like I said, what kind of defines whether an image is compliant or not compliant is our assurance policies. We can have assurance policies for your image, for your Kubernetes environment, for your underlying host, your functions, and VMware TAMs as well. In this case, we'll look at our default image policy here. Again, the idea with the policies is you can actually set up scopes where it's only looking at certain images or certain registries or repos. You can set up integration where if it's Aqua is integrated with your CI/CD pipeline, we can actually fail the build at the last step when it's scanned by Aqua and it doesn't comply with this policy. These are all the different controls you see on the left side that are you can enable for your image policies, and the enable controls are showing up on the right side. One of the main ones that we have enabled is the vulnerability severity, which is basically saying any images that have vulnerabilities high or above will be marked as non-compliant and will not be allowed to run in your environment. You can enable other sensitive data controls, super user controls. You can actually, so these are a host of different controls, set up based on, you can block certain images, I'll only allow certain images, stuff like that. So it's pretty configurable. And similarly to that, we have are runtime policies. Again, the idea with the runtime policies, again, is to make sure that you control or you guide your micro enforcers or your enforcers to do or kind of monitor your workloads and ensure that they're within your compliance policies that you set up. So we have these runtime policies for your host, for your containers, for your serverless functions. In this case, let me just look at our demo policy for the container side. Again, you can set up policies based on different scope. You can set them up for different types, just specific containers, certain specific containers using certain images, utilizing Kubernetes, just certain clusters and namespace. So you can kind of configure the scope there. And then one of the cool things with the runtime policy is you can run it in either audit mode or enforce mode. The idea there is with audit mode, you can just let it run and detect and alert what's going, if there's something happening in your environment. But if you run it in enforce mode, Aqua can actually actively protect and block bad things from happening in your runtime environment. And here you see a host of controls showing up on the left side. The enabled controls are showing up on the right side. These controls are basically for all the different enforcers that we have, but if we're specifically focusing on the Fargate side, which utilizes the micro enforcers, these are the controls that are available for the micro enforcer to protect at runtime. And some of the good ones to use again is this drift prevention. As I mentioned before, this single checkbox here is going to ensure that your containers are immutable and nothing that wasn't part of your original image when it was being built will, anything that wasn't part of it will not be allowed to run, whether somebody tries to modify anything. Another good control here is block non-compliant images. So even if Aqua marks an image as non-compliant, and even if somebody tries to manually deploy that container using that image, they will not be allowed to do it. Similarly, you can do block unregistered images, which is going to prevent rogue images from getting deployed in your environment, because if Aqua hasn't scanned it, Aqua enforcers will make sure that those rogue deployments or those rogue items will not be deployed in your environment. So again, once you've done that piece, you get all that results from your vulnerabilities. What's next? What do you do then? It's cool that you got all that information from your vulnerabilities, but a lot of time security teams and operation teams struggle to figure out what to fix first. So to help with that, Aqua has come up with this, contextualized risk-based insight that prioritize the vulnerabilities for you to help you, focus on what to fix first. So if you look at here in this environment, I have about 6,000 vulnerabilities within this demo environment. But really, the ones that I need to focus on, if you look at all the way to the right, are about 95. So these are the vulnerabilities that have remote exploits available and they're actively running in my environment. So these are the ones that I really need to fix first before I can tackle the other ones. And again, I'm being provided with details on whether there's an exploit available for it, or if there's a vendor fix for this vulnerability that will show up here, what the fix version, the exploit information is available. And another cool thing that I want to highlight here with Aqua on the runtime side is something called reshield. So this can actually come in handy for your zero-day attacks. We saw that last year with the Log4j stuff happening towards the end of last year, where what we can do with reshield is something called virtual patching. So what we do is basically with reshield, we can custom design a runtime policy just around that particular vulnerability, and you can actually enforce it at runtime, make sure that nobody is exploiting that vulnerability while you're actually your developers are fixing the issue, but you still don't want to take down your running application. So with this virtual patching, you'll be able to, securely run your application and make sure, nobody is able to attack it at runtime. And once the fix is done, you can actually deploy the final version. So again, this is something pretty unique to Aqua that Aqua does. Last thing I'll show here is what we call our the audit log, where we were able to actually get all that information, forensics information, loaded into Aqua, whatever was happening in your environment. We're able to log that information, and then all of that information can actually feed back into different integrations that we have with log management systems, whether it's the Amazon system or some other ones. We can integrate with key secrets management stores where we're able to securely manage your applications. One last thing I want to show before we switch back and wrap it up here is the pod injection piece where I was going to show. So if we go into our enforcers here, I was going to show you that one little checkbox that we came up with. Here it's a little down here, but this enable pod injection piece, one checkbox is going to help you protect your EKS environment running on Fargate and then automatically put your micro enforcers out there on that setup. With that, I'm going to move back to my demo environment here, and I'm going to go ahead and stop sharing my screen. And towards now, basically, I just wanted to highlight after you've seen the demo, like how do customers utilize Aqua and Fargate together. So here we just have a quick case study in front of you guys where basically we had a global provider of financial service analytics that had a very, very complex cloud environment where they were utilizing a host of combination of different environments, including AWS Fargate, and they actually wanted to sort of scale pretty quickly, utilizing all the benefits that Stephen had mentioned about Fargate. So they really wanted to focus on the Fargate side of things and scale pretty rapidly. But they had a big roadblock where they weren't really sure of how to effectively secure that Fargate environment. That's where Aqua's micro enforcer logic came in, and because it's purpose built and integrates very well with Fargate, we were able to successfully develop a strategy where we would set up comprehensive runtime policies for them to utilize in their environment and successfully deploy and scale their Fargate environment utilizing Aqua and kind of have that confidence in that security solution, which again, like we've talked about it actually resulted in their team focusing less on managing their infrastructure or securing it and more towards actually developing their product and working and focusing more towards their customers, which again, it's a domino effect, right? So it helps them improve their efficiency and productivity and obviously in turn business goals and revenue. So it's kind of, the idea here with utilizing Aqua and AWS together is to take that security concern away from you and then help you scale your business pretty quickly, throughout the development part of it. And then, Cody, now it's a good time to take any questions and we'll answer any questions that come up. And while you let us know about what those questions may be, I'll just kind of leave it here with some information about where you can get some more details about AWS and Aqua and what we're doing together. So some of the resources here. All right, I'll hand it back to Cody here.
Well, Farhan, thank you so much. I'll also invite you back on camera now as we do have some questions that our audience has sent in. Hi, Farhan, how are you?
I'm
good to hear. So our first question reads, can you set acceptance gates for image assurance policies?
Okay. Yep, that's a good question. Yep, as I mentioned in my slide deck, yes. So at each stage of your application development lifecycle, we can set up these policies, and for sure, yeah, we can set up those custom controls or acceptance gates at that build stage, if you want to call it, where we're making sure what's good for your what constitutes a good image. And then Aqua can make sure that it adheres, anything that your developers develop, we adhere to those policies, and anything that doesn't, that can be marked as non-compliant.
All right, so if the enforcer is running in prevent mode and it stops a container process at runtime, does it disrupt application availability?
No. The way the enforcers actually work is they make sure that your applications are doing what they're supposed to. So they won't stop any proper functioning of your applications. They will only target anything that wasn't supposed to be running. So if you have any malicious activity that's happening, somebody gets access to your container, tries to download a malicious file, or modifies an existing file. So Aqua can actually catch that piece. The enforcers can catch that piece that something got modified. So they will prevent that modified thing from attempting to run in your environment, or a newly downloaded or executable to run in your environment without actually affecting the actual container application. So it'll only stop the attacks and not your application.
So does the pod enforcer work on ECS as well?
The pod enforcer piece will not work for ECS, because pod enforcer, which kind of does the automated injection of the micro enforcer, only works with the kube enforcer, which requires the Kubernetes service running. So the pod enforcer feature will only work with EKS on Fargate, not with ECS. With ECS, we will have to utilize a regular micro enforcer, either by deploying it as a sidecar or injecting it as part of your original application.
So in that same vein, how does sidecar injection affect the pod's resources for deployment on Fargate?
I don't have definitive numbers from what our research team has looked at it. It does not significantly impact, because it's a very low footprint container that's running with it. So we've had instances where we've had pretty large Fargate deployments where Aqua has actually been used, and we haven't heard any negative resource consumption feedback from our customers where they said, hey, it's kind of bogging down their environment, or it's kind of causing additional cost to them. I mean, I'm sure there's some additional cost, but the compute size of that's going to be very limited, because Aqua is not really actively doing anything. It's just sitting there monitoring.
So it's might be a little bit of a similar question, but is there an upper limit on the number of Fargate containers Aqua can secure, and what is the largest deployment?
Technically, I mean, if you think about it, there's not really an upper limit per se, because Aqua can, again, scale out pretty easily. So if we are having an extensive environment that requires a large number of containers, you can actually have multiple instances of Aqua server spin up, so which can handle, like, you can spread the load around. So it's not really, there may be specific numbers on individual servers that, how many workloads it can protect, but really that goes out of the picture with, you can have multiple instances that can scale out pretty easily. And the second part, I believe one of our customers that I mentioned in one of the case studies, or the example that we gave, I think, if I am not wrong, they were using approximately about 100,000 Fargate containers, approximately. It's close to that. So or at least they're licensed to use that. So they're pretty close to that. So that I would say would be one of our largest deployments up to date.
So how long does Aqua take to update the enforcer, or new admission controller policies? Do I have to redeploy my Fargate containers?
Actually, no. So basically, you do not have to do any redeployment of your container. So all these changes to your policies that I was showing you at runtime, you can kind of make those take effect at runtime without having to redeploy. And that's one of the beauties of Aqua. Like, all these policies take effect at runtime without the need for redeploying or restarting your applications, and again, affecting critical business needs. So it will work in line.
Great, thank you. So can containers running in Fargate be monitored using performance monitoring tools such as New Relic, or is CloudWatch the only option?
Aqua actually, again, in my specific slide, I was kind of focusing on some of the features that we integrate within AWS's services, but Aqua as a tool itself is technology or cloud and agnostic. So we can pretty much integrate with all the different tools and technologies out there. But again, we may have, I don't believe we have a native integration built. I'll have to check if we have a native integration built with New Relic. But if we don't, we do support your standard, webhook and syslog protocols where all that information can be relayed out. And again, our team's constantly working on adding those extra, if there are softwares or technologies being used out in the industry and they're pretty popular, we are working towards getting that integrated within Aqua, whether it's on the uh, upstream side of Aqua, on the dev side, or on the downstream side, where you're trying to push those results out. So in short, I'll have to check. I can get back to you on that one, but I don't, off the top of my head, I don't know if we have a native integration build, but we should be able to get any of the tools working.
Awesome.
Any other
So
questions you see?
Yes, so I'm seeing two more, but it looks like they were addressed through text, but we can just lightly touch on them over the air for the rest of our audience. Do micro enforcers have an interactive learn mode, or are the rules addition manual?
There's not really. I wouldn't want to say there is a like a learn option. I mean, it's a complicated question, and I understand. Like you kind of almost have to. You can. I don't want to, like, again, it gets complicated. You can run it in the learn mode type of option, but ideally the idea is you can sort of run it in detection mode where it kind of tells you what's wrong in your environment without really blocking things. And then once you know what it detected, you can, start refining or closing the loop on what to block. So in a way, yes, I mean, it'll definitely detect what's bad in your environment automatically.
Awesome. So Farhan, it looks like we do have one final question. Does Aqua have a free version?
So again, like I said, it's an interesting twist. So it's not Aqua's free version, but like I mentioned, Aqua is a strong proponent of open source software. So for each of our modules that we have, whether it's supply chain security or your infrastructure or your runtime side, we do have a bunch or host of open source tooling that a lot of folks use. I did mention Aqua Trivi, that is the most popular open source vulnerability scanner that's out there. We're constantly enhancing the features that our open source tools have, and of course, then we build our enterprise solution on top of it, and then we have a commercial Trivi scanner as well. Similarly, on the infrastructure side, CSPM side, we have Cloudsploit, which is our open source version of the CSPM solution. And then on the runtime side, we have, we call it Trivi's little sister, Tracy, Aqua Tracy, which is kind of supporting your runtime protection rules, where it's utilizing that eBPF technology, where we're monitoring those. We're doing behavioral analysis on your running containers and making sure, not only are we looking at your static signatures and vulnerabilities and stopping those, we're actually monitoring the behavior of the applications as well to make sure they are not doing something weird or some in-memory attacks that may be happening that, regular scanning may not catch. So that Aqua Tracy provides that little bit of flavor on the open source side. It may not be as extensive in its, categories of rules defined to capture stuff, but it gives you a nice little flavor. So in short, while there's not really an Aqua free version of the whole platform, each section you have individual open source products that you can utilize. And I'll mention one more here. For the Kubernetes side, we have KubeBench and KubeHunter that focus on Kubernetes, pen testing of your Kubernetes environment and making, benchmarking your Kubernetes environment. And similarly, we just launched on the software supply chain side an open source tool called ChainBench that is, again, trying to make sure that your software supply chain side is adhering to your, industry benchmarks and stuff like that. So in a way, Aqua does have free versions per se.
Well, thank you so much for that, Farhan. It looks like we've exhausted our questions. And before I go into my closing remarks and giving away some gift cards, I wanted to give you the opportunity to have the floor one last time if you had any parting words or anything you'd like to leave our audience with.
And I think I am definitely good here. Just wanted to kind of highlight again, feel free to explore the offerings from both AWS Fargate side and Aqua side. And if you have any questions, I will be happy to help you out with any detailed information you need, whether it's, specific to securing the Fargate instances or in general, securing your cloud native infrastructure. So Aqua, like I said, provides that whole CNAPP platform security. So any questions, feel free to reach out to us. There's a bunch of links at the end of that slide that provide, all the information. That should be good enough for people to reach out to us or learn more about Aqua and AWS.
Great. Well, thank you so much. I'd like to thank Stephen as well, who couldn't make it to today's Q&A, but I'd like to thank both you and Stephen for all of the hard work that went into putting together both the presentation and the demo. So thank you so much for your time and your expertise.
Thanks, everyone.
To our audience, just a quick reminder that this session was in fact recorded. So following this program, you'll receive an email with a link to access the recording on demand, or you can find it living on the DevOps website at devops.com/webinars, and just be sure to look in the on-demand section. So I did promise 4 $25 Amazon gift cards to give away. Our first winner is Claudia M. Our second winner is Mark F. Our third winner is Craig S. And our fourth and final winner is Bijendra A. So for our 4 winners, congratulations. Keep an eye on your email inbox to collect that gift card. But if you do not see that email, check your spam folder. I would like to thank AWS and Aqua Security for sponsoring today's program. And to our audience, thank you so much for sticking around through the entire duration of today's presentation. We do ask for one extra moment to fill out a brief survey that should pop up on your screen as soon as we close out. But otherwise, we hope to see everyone at an upcoming Techstrong Learning program. Everyone have a great rest of your day. Farhan, thank you so much.